Hello my people, how are we doing? Now this video might be helpful for some others might not really care. I'm going to go ahead and show you the proof for the product, reciprocal, and quotient rule. Reciprocal rule I'll define as we go along. You have not seen it, but it's sort of like it's sort of a stepping stone on the way to the quotient rule. Now the product rule states that when I have f of x times g of x, my derivative is going to be the sum of the first times the derivative of the second plus the derivative of the first times the second. You're like, how in the world do they ever come up with these things? I am so glad that you asked, okay, because I am now going to tell you. Now, what we have is, when we're dealing with this, we know that this is also equal to the limit as h approaches 0 of f of x plus h, g of x plus h, minus f of x, g of x, all of that over h. And you're like, well, that doesn't seem like a step forward. That seems like a step backwards. Well, that's because we have to take that numerator and we have to actually change the form. Okay, I'm sure you're shocked. Let's think about it geometrically. Okay, now we're dealing with the product, right? F of x plus h and g of x plus h. Well, that would be the area of the whole rectangle, right? Now, the product of f of x and g of x, well, that's the product of that small rectangle, right? And so if you kind of look at it again, product of the big rectangle minus the product of a smaller rectangle. And so what we need here is we need to find the area of these three rectangles, because those three rectangles wind up being the difference, right? Okay. Now, if this whole big long thing is f of x plus h and this small thing is f of x, then this is f of x plus h minus f of x, right? This distance right there. Okay, and this distance right here is g of x plus h minus g of x. Okay, and so using these particular measurements, I'm going to basically write down the areas of those three rectangles. Let's go ahead and do it for rectangle A. Now, I know the area of rectangle A is going to be f of x plus h minus f of x times g of x, right? Because if this edge right here is g of x, then this edge right here is also g of x. So g of x times the difference of f of x plus h minus f of x. So we have the area of A. The area of B is going to be f of x plus h minus f of x times g of x plus h minus g of x, right? And of course, the only thing that we have left is to find the area of C, which, as I'm sure you probably have already figured out, and I'm going to have to sort of wrap it around down here. It's going to be f of x, because if this is f of x, this is f of x. It's going to be g of x plus h minus g of x times f of x. Okay? Now those three areas are going to help us rewrite the original numerator. Are you ready? Okay, great. So what we have here, if we want to go ahead and rewrite this, I'm going to start way over here because I'm going to need just a little more room. Okay? Now, we're going to go ahead and mix up the order a little bit. We're going to do ACB. So f of x plus h minus f of x times g of x plus g of x plus h minus g of x times f of x plus f of x plus h minus f of x times g of x plus h minus g of x. Whew. Okay, all of that over h. And you're like, wow, Mr. Forth, you didn't just take one step back, you took 2 steps back. But notice that I have 3 different terms in the numerator, okay? I have one term here, I have one term here, and I have one term here. And of course, that means that I can separate the fraction. And I want you to tell me what those 2 look like right there. So all I'm going to do is I'm going to rewrite this strategically. The limit as h approaches 0 of f of x plus h minus f of x, all of that over h. And instead of putting the g of x in the numerator, I'm actually just going to put it right next to there, because that's legal, right? I can do that. And I'm going to do the same thing with this next one. I'm going to go ahead and put g of x plus h minus g of x, all of that over h. And then I'm going to put the f of x right next to it. Now, this next one is going to be just a little bit wonky, I suppose. We have the limit as h approaches 0 of f of x plus h minus f of x, all of that over h, times g of x plus h minus g of x. Well, that's a little bit different, right? Because once I think about it, this right here is f prime. This right here is g prime. This right here is f prime, but if I go ahead and have to apply the limit to this one, that's 0. Okay? So what happens is this one comes down as f prime. This one, of course, just remains g of x. This one comes down as g prime. This one remains f of x. This one comes down as f prime, and this one comes down as 0. Well, if that's a 0 term, then the derivative is right here. And that is exactly what we have in the original, if you look up there, because addition and multiplication are commutative. And therefore, I have just proven for you the product rule. Isn't that just neato? Okay? Now, let's go ahead and do the reciprocal rule. Now, the reciprocal rule is basically asking, what is the derivative of the reciprocal of a function? So, obviously, if I have the derivative of g, the way that we write that in terms of notation is g prime. What we want, however, is to find out if there is a general form for 1 over g of x. Okay? And there actually is. Okay? You don't really need to know it. I guess it might be helpful if you're the memorizing of formulas kind of guy or gal. But let's go ahead and restate 1 over g of x in terms of, guess? Yes, the limit definition of a derivative. Okay? Now, if we do that, we wind up with 1 over g of x plus h minus 1 over g of x, all of that over h. And of course, you guys, if you paid attention at all the last 2 years and you've been paying attention at all for the last couple of weeks in the videos, this ought to be second nature. We go ahead and we multiply through by what would have been the common denominator. Okay? And when we do that, we're going to get the limit as h approaches 0 of g of x minus g of x plus h, all of that over h times g of x times g of x plus h. Okay, well, that really shouldn't be all that bad. All we have to do is sort of reformulate it sort of a little bit, okay? So what we're going to do is remember that the limit of a product can be broken apart into the product of several limits. So we're going to go ahead and leave this like this, okay? And then we're going to have another limit as h approaches 0 of 1 over g of x plus h. And then we're just going to have 1 over g of x. Well, can I do that? Can I pull the g of x out of a limit? I can, because this limit, the only thing that is variable for the limit is h. So anything that is not h is a constant with respect to the limit. Now, it's not a constant qua constant. It's not a constant for everything, but it is a constant with respect to the limit, and therefore I can pull it out. So anything, if your limit has to do with h, anything that's not h related can be pulled out, okay? Now notice that this is the derivative of g, except for the numerator has the order swap. Now how do I get a difference to go back the other way? How do I flip a difference? That's right, I multiply by negative 1. So this is not g prime, this is negative g prime, right? So that first limit is negative g prime. Now what happens when you evaluate this one as h goes to 0? Well, it winds up being 1 over g of x, and of course you already have 1 over g of x, so this winds up being negative g prime over g of x squared. So I've basically told you the formula for a reciprocal function, okay? That is how you can formulaically take the derivative of a reciprocal function. Now, that is going to be really helpful when I start talking about the derivative of a quotient function, right? Because I can actually pull that apart into a product, f of x times 1 over g of x. And if that's the case, then what I really need is f of x times the derivative of 1 over g of x, okay, plus the derivative of f of x times 1 over g of x, right? The first times the derivative of the second plus the derivative of the first times the second. Okay, well, f of x times negative g of x over g of x squared, since we just derived the formula for that, plus f prime of x times 1 over g of x, okay? Now here's the thing. What I need to do now is to get a common denominator. So this one needs to be multiplied by g of x over g of x, right, in order to get a common denominator. And I have negative f of x, sorry, this needs to be a prime up here in that numerator, g prime of x plus f prime of x times g of x, all of that over g of x squared. Well, that should look rather familiar, because all we got to do is turn it around and mix up the order just a little bit, legally, of course. And we have our quotient rule formula. The bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And that is how we get the product rule, the reciprocal rule as a stepping stone, and then the quotient rule in terms of how to find a derivative for a quotient function. I hope that that helps sort of solidify why these things are the case. Hopefully that gives you a little more texture in terms of understanding them. In the next couple of videos, we're going to go ahead and walk through some examples, including some equation of tangent line examples with the derivatives that we have procured by using these rules. Okay, so I hope that's helpful, guys.